This video is going to cover conditional statements. And the examples I go over are going to try to answer the essential questions: what are the various kinds of conditional statements, and how are they used to reach conclusions? An example to start out with is rewriting conditional statement in if-then form. So all PVHS students are cool. We can rewrite that to say, if you are a PVHS student, then you are cool. Here's another example. Numbers divisible by 9 are also divisible by 3. Can be rewritten as, if a number is divisible by 9, then it is divisible by 3. Conditional statements can be, can be true or false. So are the following conditional statements true or false? If false, provide a counterexample. First one, if a number is odd, then it is divisible by 3. At first, maybe that might be true, but taking a second to think about it, this is a false statement. If a number is odd, then it is divisible by 3. A counterexample would be the number 5. So 5 meets the condition, 5 is odd, but 5 is not divisible by 3, so the conclusion is false. Another example, if x equals 5, then x squared plus 2x equals 15. We need to do a little computation to see if it's true or false, so let's do x is 5, so 5 squared plus 2 times 5. 5 squared is 25. 2 times 5 is 10. This is equal to 35. So this statement is false because if x equals 5, then x squared plus 2x equals 35. And that's our counterexample to show that the conclusion is false. Okay, here's a diagram that those lines there are indicating we're looking at a right angle, and we have to decide whether the statement about the diagram is true, and based on what we've already learned in the course, explain whether it's true or not. So the first statement is line AC is perpendicular to line BD. This is a true statement because we know this notation should be a box there. We know that notation indicates perpendicularity. So statement A is true. Statement B, angle AEB and angle CEB are a linear pair. So AEB is the angle here in blue. This is the blue angle. And then angle CEB is the right angle marked with the red square. And they are a linear pair. That is a true statement. We know that's true because they have an adjacent side. They're angles that share an adjacent side, namely the ray EB, and their non-adjacent sides are opposite rays. So ray EA and ray EC are opposite rays, so that fits the definition of a linear pair. So B is also true. Last one, C, ray EA and ray EB are opposite rays. Well, they share a common endpoint, which is point E, but EA, ray EA and ray EB, and ray EB are not opposite rays. This is false because they are not collinear. To review some vocabulary here, statement P will consider the example two planes intersect. Statement Q is two planes contain the same line. the notation here is that P implies Q, or if P, then Q. So we can write that as if two planes intersect, then they contain the same line. The notation here for part B is the negation of P implies Q, or not P implies Q. And if you had to write that statement out using words, it should look like if two planes do not intersect, then they contain the same line. Example C here, P implies not Q, or if P then not Q, should look written out like if two planes intersect, then they do not contain the same line. And the last example, part D here, is not Q implies not P, or if not Q, then not P. So what does that look like in words? If two planes do not contain the same line, then they do not intersect. Sticking with this same example, what's the relationship between the statement P implies Q and the statement not Q implies not P? So a statement and its contrapositive. And we know that those statements are equivalent. A conditional statement is equivalent to its contrapositive. So again, here are these same two statements: two planes intersect, two planes contain the same line. Let's take a look at the four types of statements we can make. The first statement we're going to do that we saw before is P implies Q. If P, then Q. That's our conditional statement. Equivalent to that is the contrapositive we just saw. If not Q, then not P. Well, what's the converse of the conditional statement P implies Q? That would be Q implies P, or if Q, then P. And then the inverse is if not P, then not Q. One last example: if you have a statement P and a statement Q, and you want to write the statement with the double arrowed lines like this, what does that turn into in words? Two planes intersect if and only if they contain the same line. That means if P then Q, and if Q then P. So if and only if.